Welcome to an introductory lesson on function, their characteristics and properties. Prerequisites. So before we head on to the lesson, these are the things that you should at least be familiar with. How to evaluate functions, because in the lesson you will encounter different kind of functions, linear, quadratic. So you should be aware how to evaluate and find solutions of those functions. Parent functions and transformations. So whenever we plot a function graphically, its simplest form is called the parent function, and we can apply different kind of transformations like translation, dilation, and reflection on the functions, and the function would change. Translation is just the sidewise movement of the graph. Dilation is the stretch or shrink of the graph, and reflection is just the flip or mirror image that is produced from the graph. Modeling. So modeling is just representing how a real world works. So one should know how to extract data from those problems. So let's start with functions. So a function is just a relation between two variables. For example, y equals to 3x or f of x equals to 3x is just two ways to represent the same function. Y here is the dependent variable, and x here is the independent variable. Okay, you can also think of y as the output values, and you can think of x as the input values that you can give to the function. You can take different values of x, like if you take x equals to 0, then y equals to 3, 0 becomes 0. Okay, so you can clearly see that the value of y depends on the value of x. You change the value of y, the value of you change the value of x, the value of y would change along with it. That is why y is the dependent variable and x is the independent variable. So now we know what functions are. There are certain conditions that a function should satisfy. Only then it can be called a function. The first thing is that one value of x for every value of y. So x cannot have more than one value. Okay, like if you have a function x and x square is the, like if you have the value x and you have the function x square and you have different values 2, 4, 6, and for 2 you have 4 here, so you have 16 here, and you have 36 here, right? It cannot. So if you say that this is a x square is a function, then the first condition is that if 2 cannot have more than one value, it cannot be the case when where 2 is equals to 4 and 2 is also equal to 16 at the same time. So 2 can either be equal to 4 or 16, only one. Both cannot be true. Okay, and the second thing is that every value in x should be related to the function. Okay, so there should be no, like if for example if you have the input value 8 and you don't have its output, then you can say that this is not a function. So every element in the x should be related to the x square or the output value. So these are the two conditions that are to be satisfied if you say that you have a function. Let's look at now a different function representations. We can represent a function algebraically, numerically, or graphically. Algebraically, they can be different kind of functions, different kind of equations, like we have this trigonometric function, we have this quadratic function, and we have this exponential function. So you can encounter different kind of equations when a function is represented algebraically. Numerically, we either have ordered pairs. Okay, we either have table of values or we have this mapping function. So numerical representation is one of the easiest way to find the domain and the range of the function when a function is given in the numerical representation. So graphically speaking, graphically we only have this graph that we represent in the xy plane, and in order to see that whether we have a function or not, we use a test called the vertical line test for it. So let's discuss what vertical line test is. So In case of a vertical line, as you know that we can represent the function graphically as well, and when we represent the function graphically, this vertical line test is used to see that whether we have a valid function or not. The test is pretty simple, that we draw vertical lines on the graph. You can draw as many as vertical lines you want, but the only condition is that the vertical line cannot pass through more than one point on the graph, because if it passes through more than one point on the graph, then you can say that uh, graph is not a function. Like in this case, on the left hand side yellow line, it passes through 2 points, one here and one here. Okay, and on the in this blue line, only touches the graph at this point. Okay, so you can see that on the left hand side here we do not have a function, because this graph fails the vertical line that it passes through these 2 points. And on the right we have a valid function, because this line right here passes through only one point. So let's talk about domain and range now. So domain are the set of all the input values that a function can take, and as I told you that input values are independent variable values. Okay, and the range is just the set of all output values, and the output values are just the dependent variable values. Like we saw in this example, y equals to 3x, that this y right here is the dependent value and this x right here is the independent value. Okay, because the value of y depends on the value of x. You change the value of x, the value of y would change along with it. Okay, because you have this function and you plug in different values, you get different values. So you can think of the domain and range as the input values for this function. Okay, and the output value of the function. So whatever you can input into the function, whatever values this function can take without getting undefined, is the input values, and they are the domain of the function. And whatever values, when this function has processed your input values, it produces are the output values, and they are called the range of the function as well. So for example, if we have this numerical representation of our data, that is an ordered pair representation, we can easily see that this x relates to this y, right? Because in this ordered pair representation, it says that 2 relates to 4, 3 relates to 5, and so on. These are all the x values and the other ones are the y values. Okay, so the domain is just the x values and the range are just the y values. Okay, so let's take a look at a couple of more examples, and first we will see whether we have a function or not, and then we will move on to find their domain and range as well. So in this graphical representation, we just have to see the vertical line test, okay, to see whether we have a valid function or not. You can draw one line, you can draw multiple lines, as I already told you, and if it only touches the graph at one point, then you can say that you have a valid function. So that is true in this case. So we have this graph represents a function. So let's talk about domain and range now. So first of all, let's talk about domain. Domain are just the x values, right? We know, and range is just the y values. So if you see that that this graph becomes a straight line here, right? It becomes a straight line. So it can go to negative infinity if we talk about in terms of x, -4, -6, -8, right? It is going on from here to the negative infinity. What about the right hand side from this 0? So 2, 4. So the curve is so the line is a curve here, you can see, right? When the line is a curve here, it means that it is something like this, right? It is going to go something like this. So it will increase over the time, right? Because if it is a straight line, it won't go beyond 2, but since it is a curve, so it can go beyond 2 as well. So it can go to positive infinity as well. So in set interval notation, we can easily see that the domain is from negative infinity to positive infinity. What about the range? For the range, you need to see the y-axis. So the y-axis, you can clearly see that the value of y cannot go beyond -2 because the graph is a straight line here. It cannot go below this point. Okay. So other than that, it can take all the values of y. Okay. So the domain is just all the real number values depending on the value of x, and the range is just the value of all the real values except for the value that are greater than -2 because it cannot go beyond -2. So what about this function? For this function, we can clear either it is a function or not. We have to make a table for it. So we make a table for it. We take the value 0 and then three positive values and 3 negative values. Okay, and then we evaluate it there and then apply the conditions that we have done. The first condition is that x cannot have more than one value, right? You can see that every x has one value, not more than one value. The other thing is that every input must have an output. So you can every input has an output. Both the conditions are satisfied, so we have a valid function on our hand. What is the second condition? The second condition, what is the domain and the range? So domain are just the input values, right? You see that this is the domain and this is the range of the function. For domain, you can see it can take all the values except for 0 because at 0 the function becomes undefined. Okay, it cannot take 0. So what about the range? So range are the output values, and you see that you have a x square here, right? So whatever value you take, you'll end up with a positive value. That is the case here. You can see in the table. Okay, and you always end up with a positive value. So domain is just the real number, right? And it cannot be 0. And range are all the numbers except for the fact that y is always greater than 0. It is always positive. We do not have negative values for this range of the function. So this is a mapping representation of the function. It is pretty straightforward because these values are the input values, x values, and these are the output values, and you are mapping this to the output to its output values, and and let's say if it is x square. No, I'm just saying that if the function is x square, you can to see that what is happening here. Okay, so if you see that if the function is x square, this value right here is the domain and these values are the range here. Okay, and is it a function or not? The two conditions are easily satisfied that x cannot have more than one value. Every x here has one y value. Okay, -1 equals to 1, 0 is also equal to 1. So two x's can have the same y value. Okay, but it cannot be the case that -1 equals to 1 and -1 equals to 2 at the same time. Okay, so be careful in this. So we have a valid function, and what about the domain and the range? The domain and the range are pretty straightforward in this case. Okay, so let's talk about modeling. What do we see in modeling? Modeling, as I told you, is a real world problem, and we'll try to solve this real world problem. Okay, we'll get the function at the end and then we will algebraically solve that function. Okay, as well. So the problem is that Jonathan and Tina want to build an outdoor skating rink. So look for clues. Okay, whenever you are solving any problem. So the first clue is that they have enough material to make a rectangular rink. Okay, so they want to make a rink and the ring is rectangular in shape. Okay, that is the first clue. And the area is of the ring is about 1800 meters square. That is your second clue. They do not want to purchase any additional material. They know from experience that a good ring must be approximately 30 meters long, then it's wide. This is your third clue, in which they are saying that the difference in the length and the width of the ring should be at least 30 meters. So these are the three clues that they are giving you, in which what they are giving you is that they want to build a rink, and Jonathan and Tina want to build a rectangular rink. They have given you the area of the rink, and they have told you that the difference in the length and the width of the ring should be at least 30 meters. So now let's see that how we can solve it. And what do we want to find out? We want to find out the dimensions of the ring. So we want to find the length and the width of the ring. Okay, so let's say that let x represent the length and y represents the width, Now since area is length into width because we have a rectangle, so what is the area? Area he says that it is 1800 and length is x into y. So this is your equation number 1. So you can write this area in terms of your length or width. I'll write it in terms of y. So that is your width. So in terms of y, it becomes y equals to 1800 by x. That is your equation number 2. So what about the second condition now, that the difference in the length and the width is 30 meters. So we do not know the name of the equation. So let's say let f of x be the difference in length and width. Okay, so f of x is the difference in the length minus width, and the difference is 30 meters, right? The length is x and the width is y. Just plug in the values, you get x minus 1800 by x. You just solve it, you'll get x square minus 1800, and just rearrange it, you'll get x square minus 30x minus 1800 equals to 0. So see, you get a quadratic equation here, and that is a function, and now you have to evaluate that function. So you should know how to evaluate this function. I'll write their factors. So when I write their factors are x minus 60 and x plus 30 equals to 0. So x equals to 60 and x equals to negative 30. So we cannot take this solution, right, as x is length, right, and it can't be negative. Okay, it can't be negative. So we'll drop this solution and we'll only take this solution. Okay, this one. So what is our length? So our length is 60 meters. So what about the width now? So let's use equation 2 for width. So y equals 1800 by x. So you get 1800 by 60, you get 30 meters. Okay, so width is 30 meters. Okay, so this is the things you were looking for, your length and the width. Okay, so the dimensions that produce the area of 1800 meters square with 30 meter, that is right, that is 30 meter apart. That was also the condition, that was 30 meter, that is 30 meter apart, or 60 meter into 30 meter. Okay, so you can see that how we started and what we ended up with, right? We first looked for the clues, then we moved on and saw what we had to find. We had this function, we had two unknowns, x and y. So we had two equations and then we solved it and we got the thing we were looking for. Okay, so let's move on to the absolute valued function, and absolute valued function is commonly referred to as the magnitude. Okay, and how it is represented? Is represented by a variable x. If let's say in this case, so it is represented f of x is x modulus, and this sign right here is the modulus sign. Okay, is the modulus sign. The modulus of any quantity is always positive and it is its absolute value. Okay, graphically it is represented by this v-shaped line. Okay, v-shaped line, this v-shaped, and you can see this in graph as well, that from 0 if we move on to positive, or if we move on to negative values, that the value of the y is always positive. Okay, so the value of y is always positive no matter what the input values is, because of this modulus sign which turns every negative thing into positive. Okay, so if you write this in the form of piecewise function, says that if the value of x is greater than 0, then you have a positive x, and if value of x is less than 0, you have a negative x. Okay, And in terms of number line or algebraically, we are not concerned about the negative sign. So if you move from the number line either on the right or onto the left, you should get 4 and you should get negative 4, but because of this modulus sign you end up with 4. Okay, so on a number line it will only give you the distance from the 0. Okay, it will not tell you about the negative sign. It will drop this negative and it is not concerned about the negative sign that you have. Okay, and algebraically as well, that is the same case algebraically as well, that algebraically you'll end up with a positive output at the end because of this modulus sign, but no matter what the input is. Okay, so thank you, and that's it for this lesson.